Okay, this chapter is all about ionic compounds. And there are three types of ionic compounds. Binary compounds, which we're talking about today, transition metal compounds, and polyatomic ion compounds, which can be intermingled with the others, with the transition and just the main group metals, which we'll be talking a lot about today. So what is an ionic compound? Well, an ionic compound has to have at least one metal. And so there are no other requirements beyond that. The fact that they are ionic means that they are going to form solids at room temperature, and they should create a geometric shape with a very distinct pattern, what we call those crystal lattices. So those are the two properties of ionic compounds. Today we're going to talk about binary compounds. The word binary means two, as you probably know from algebra. But binary means two elements, not two atoms. So you've got to be careful of that. In other words, if we have two elements, we have three of one and five of the other, as long as you only have two distinct elements in the compound. And they have specific names and properties due to that. So let's take a look at that. First of all, let's take a look at the most common of all of the ionic compounds, at least that you're familiar with. Maybe not in terms of ionic compounds, but definitely a very common compound. And that is the result of the reaction of sodium and chlorine. Now you all know what you're going to get when you react to this, but let's find out why, okay? First of all, when you deal with that ionic compound, I guess another area that you have to pay particular attention to in ionic compounds is that you can have one group or one positive ion and one negative ion. You can't have more than two particles in the solution or in the makeup of the compound. We have a sodium and a chlorine. We may have two sodiums, we have five chlorines, but we've got a positive and a negative. Now, how do I know that sodium is a positive? Because when we talked about the periodic chart in the last section dealing with ions, we said that this staircase divided the chart up to positive metal ions and negative non-metal ions. These, of course, are noble gases. They're zero charge because they just don't react at all. And then the metalloids are kind of weird. We'll talk about that later on. These are the transition metals. We call these the intertransition metals, and we're going to avoid them for right now because the charges are wildly unpredictable. The charges for these 8 elements, the 2 column elements on the left and the 6 column elements on the right, are very predictable with some exceptions again. We get down to this area down here. But we're going to learn patterns today, and we're not going to deal with exceptions at all. So don't worry about that. So in taking a look at sodium, you notice that sodium is in group 1A and it's a metal. And as we said in the previous section, that metals in group 1 have a positive charge. Chlorine is a non-metal, and it has 7 valence electrons. And as we said, because of the fact that it's going to take 1 electron to push it over to the 8, it's going to take on an extra negative charge, which means the elements in group 17 or 7A, which is what we should be looking at, 7A, is going to have a negative charge because it's going to make it 8 valence electrons. Taking is going to be full. Okay, so let's use that. So we know that sodium has a positive charge, and I'm not going to put 1 in because it's just like the variable x. You never say 1x, you just say x. So it's a positive charge, it's a negative charge. And the thing that's true for all compounds, no matter if they're ionic or covalent or whatever it is we're looking at, the charges have to add up to 0. And so since we have a positive 1 and we react with a negative 1, that adds up to 0. And that means that the formula is going to have 1 atom of each. Now, the name of this if you look at it, it looks like it's sodium chlorine. But as you know from your vast experience of this compound, that this is not called sodium chlorine. This is called sodium chloride. And it's a suffix that always goes around the anion or the negative ion. And we always place the positive ion first. Always. No exception for ionic compounds. So there's a distinct pattern, a distinct set of rules that have to follow when you write ionic compounds and come up with formulas based on the charges. Okay? So let's make sure let's take another look at this periodic chart, because this is very important. Because all these have one valence electrons, they're all going to have a positive charge. So column 1A, positive charge. These all have 2 valence electrons, which is very close to having 8 if you got rid of them. So we're going to get rid of those 2 electrons, and that gives you all positive charges here. And it coincides with the Roman numeral 2A. This is why I said we need those Roman numerals, because they predict us the charge for the 8 columns. Not that case here, which is why we never looked at the Roman numerals here. 1A and 2A, metals left of the staircase. For the metals, start with aluminum, 3A, and aluminum is a metal, because even though it's on the staircase, should be a metalloid, but tell that to yourself when you drink a soda out of an aluminum can. Or as they say in the rest of the world, aluminium. In fact, that's how it's supposed to be said. It was changed by a guy who developed Alcoa, the company that we have over there in the Quad Cities. It's not called Alcoa anymore. But regardless, he changed because it sounded like something Americans would be more likely to use than called aluminium, which I don't know what this thing was there. But it is aluminium. This is changed by the guy from Alcoa. Anyway, moving on. All these right here, metals, 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 they have same charges and the 8 columns they're found in. Okay? Now, chlorine has 7 valence electrons, 1 away, as I said, so these are all going to have -1, but they all behave the same way. That's what groups or families do. They behave chemically the same way. These are 2 aways, so these are -2s. These are 3 aways, so these are -3s. And I'm talking about the green, because those are the non-metals. And then carbon, which is going to be -4.